somebody will inspect things that are coming over a network. So the goal is to look at a common man and then say how the various parameters that you are all used to can be done over distance. There are two paradigms. One is constant health monitoring. Another one is to do the health monitoring as and when necessary on a need basis. Health care provision in the large, and that I believe is what one should be aiming at if one were to promote a healthy society. Both of them require technologies that defy distance and time. That means you need a very high bandwidth and a very low latency network to be able to accomplish this. And what I have shown around the human being, the figure there, are the technologies that are developing in today's context. Many things to worry about, measurements that would have taken by extracting maybe blood from the person and then sending it to a laboratory, doing a set of measurements and so on. All these can be actually done online and in real time without much of invasiveness associated with it. Technology permits you to do that. Around the individual picture there, what is shown is the temperature, pressure, heart rate, respiration, glucose levels, blood flow, etc., which basically define the control system that drives the physiological system called the human body. See, if you look at non-invasive measurements and a lot of physics, semiconductor physics, and a very high level of competence in laser-related semiconductor physics and ability to produce them in large quantities with specialized applications built around them is now possible. Are we still connected?
Yes, sir. But, sir, we are not able to see your presentation. Can we reconnect to you, sir? Give us just 1 minute. We'll reconnect to you, sir.
All right.
It's code now. To your conference now.
Are we back? Am I audible and visible?
Yes, sir. We are back, sir.
Okay.
But the presentation.
So non-invasive measurements, which are basically through wearable sensors, can make a shift, a very, very significant shift in the way we can use technology in the next generation healthcare. The reason I'm saying this is the cost associated with the current day medical devices are rather significant, and that makes the dialogue very difficult between those who are willing to provide health care and those who are receiving the health care and those who are regulating the health care. It makes the three-way dialogue extremely difficult, and the question of affordability repeatedly comes up and the business models repeatedly come up. So if you look at invasive measurements, which are at present not easy to do away with, implantable sensors are the way to go, where there is sustained observations that are required in drug levels, toxic levels, and hormone levels, wherever it is appropriate in the case of the individual's capacity to withstand things, and also and then there is a management plane in which these are organized. So I'm referring to this part, the measurement plane and then the management plane in which they're organized. And then they form it out into a knowledge plane as necessary, as agreed to by medical experts, and then you share it with a number of domain experts. This is where we are interested in doing so. And accordingly, they can look at it and then raise an alarm if required. See, this domain expert business, individuals react differently at different situations. In fact, saying he doesn't charge. It may be useful to a rural person because that person is very expensive. The guy who is giving opinion is very expensive. Both of them don't know each other. Technology can make it happen. There could be many such instances. If you look at inside the hospital environment, the patient and whatever is picked up, hospital, these types of pictures which collect the information and consolidate and then put it up in a place, and this person can be anywhere else in the world. Locating the person becomes more important at this point in time. So you look at technologies that back up the next generation medical systems, it can even find out where is the specialist and how close is he to the person who is suffering from, in the sense that I can swipe my visa anywhere in the world and pay for even taxi fare. I can't enter, if I am watching cricket in Melbourne Stadium and get heart attack, there is no way somebody will touch me without knowing my background in terms of health. So how does one make it happen? How does one globalize it? Immediately we'll jump to regulatory frameworks and so many other things that has to be shared and so on. But we still don't have a technology that can be very guaranteed, because that's what one wants in real life. At the same time, there's no multiple copy of data, and then it goes with him and comes back when he is back to the base and attaches to the database. Database has solutions in this sense in a very limited way, but it has to be enhanced to suit this particular need. That's going to be a challenge. It's called detaching something and then putting it back. After both ways, authentication is required. If you look at pervasive computing, remote health monitoring, rural stretch, rural outreach, reaching 1.2, 1.3 billion of India, where the marketplace is, etc. I know these kind of jargons, and this go together, possible. How comfortable is it? How fast can it go? And you expect things like seat to be adjusted when you sit down and then say, this is comfortable, then seat should lock it in. You expect that to happen in today's car. Unfortunately, we don't realize that in such a car there are 64 CPUs, each one having at least 8 cores and having parallel processing capability. That's the kind of infrastructure that's there inside the car. If you pay 1 or 2 lakhs of rupees for a car, if you meet with an accident, God be with you. If you pay 60 lakhs, 70 lakhs to your car, you are guaranteed to open the door and get out, even though the car may get crashed. There's a range of things that happen with the technology and with investment and with the realization of a solution. So we should jump between the two and then say exactly what is it that we have in mind. Such automatic human-computer interaction and with the technology is a challenge. And how does one do it and how to take it forward? We are forming a system. When a system gets in place, it's as good as a religion getting into a society. Such strong feelings and boundaries will develop. It will be very difficult to become secular later. The robust wireless networking, QoS management, information security are absolute immediate requirements. I have put these in 3 different segments, and simply because they go together and they together form a suite of things from which you can form solution of tomorrow. What is happening today is that any picture that you take gets deposited into a database. In an isolated sense, this is like back of your hand, you can do it, it's not a problem at all. And you can always use it in the reverse way to reach out through any mobile system that is available, to reach out to people and to reach out to doctors and then get the attention and the mating together between the need and the availability, provision of the. You can make all these sensor technologies work together, that's not an issue. But if you look at sensors and creativity point of view, I was listening to Dr. Ramaswamy from Science and Technology. See, the sensors are moving into a new generation of sensors. It will become very small and very high resolution of tomorrow. And the challenges are dealing with less memory capacity, and limited battery power in these sensors, so they work. Preferably, it should charge itself by the movement of the human itself. If you talk about pervasiveness in computing, these are diagrams which you would have seen time and again. On the left top corner, I would like to show that monitor, analyze, predict, and treat. That triangle is what really matters all the time. And that triangle to realize, you require a large infrastructure on which you can depend on 24/7. The reliability and availability of these networks, and then the question of sustainability of these, survivability of these at the time of crises, all these become serious issues. They are partly engineering, partly social, and partly commercial. If you look at more technology terms, you have different types of architectures which finally morph themselves into one single statement for audience like you, namely the telemedicine. And when you look at telemedicine, you essentially talk about patient-related records, diagnosis, and delivery of care to some person, whether he is locally located or remotely located. And if you can do continuous monitoring, this old age monitoring at home and related provision of service is possible. We do something called brain grid in the National Knowledge Network as a model project. Autism on one end and Alzheimer on the other end of human life, private, and partnership, if it is to be included. And recently, I think Ramaswamy included one more called people. Knowledge capital leverage is seen as India's USP. We are moving from labor arbitrage to knowledge arbitrage in the case of medicine. And there is yet to be some clarity on who does what, or rather who is allowed to do what. That clarity is still missing.